This is the syllabus as per our syllabus booklet. Introduction to the composite manufacturing process, then hand layup process, which is also includes the spray layup process. So this is very primitive. This is very old method. Actually, composite manufacturing started with this only, and we can say this is a 50 years old. Beyond that, then other techniques are developed: compression molding, vacuum bagging method, resin transfer molding, filament winding, pultrusion. So it is also called as pultration. Basically, we are pulling the fiber here. So pultrusion, that word is from that. So pultration or pultration, just see what is the pronunciation. Prepregs, and then we'll see what is the effect of stacking of the reinforcement. So these few things we'll discuss in the coming next 4, 5, 6 lectures that will cover the unit number 2. So processing techniques primarily, as I mentioned, so if you are going for the structural applications and high-end applications, that is mostly the space vehicles, aircraft, and maybe automotive, then they are mostly the manufacturing techniques you have to select. There are proper developed manufacturing techniques: filament winding, autoclave, molding. So these techniques are generally used where you have to take very much precautions for all of the things, porosity and dimensional stability. Everything means structural applications. You cannot compromise anything, because there is a directly it is that particular composite material is subjected to the various, they are actually load bearing applications. So there we have to be very semi-structural applications. So they are also in marine applications, some another construction applications. So there also we have to select the proper manufacturing techniques and non-structural applications. So hand layup, spray layup generally comes under the non-structural applications. So based on the application loading conditions, these processing manufacturing process have been classified. And if you see this particular graph here, now based on the you can see here the structural at the top. In between there is a semi-structural and then non-structural, and this represents actually this statistics also is old from the book. There are there may be some changes, because every day there are changes are happening in the composite material area, but this is the general background. So when you are going for non-structural applications generally, and if the production rate is less, means the number of units required are less, then you can go for such type of manufacturing process, hand layup, then some molding processes. So for the non-structural application, again the number of units are more, then you have to automate the process, because you cannot this is a manual. Means manual intervention is required, and obviously it depends on the skills of the laborers. So you have to switch over to this, where this process can be little bit automated. So consumer applications, and this comes under this, many roof sheets or many tents and many applications are there. We have seen where we call this as a non-structural materials. Then this is the semi-structural. Then you can go for the resin transfer, molding, then pultrusion and all this. But if you go for the high-end applications, aerospace, automotive is not mentioned, but automotive is also there. Okay. Then so there this autoclave molding, then filament winding, even resin transfer molding is also comes here. So these are the very rough classification of how the manufacturing techniques are classified based on their applications and based on the loading conditions. I'm explaining these things with respect to the PMC, that is the polymer matrix composite. Now here it is again thermoset composite processing and the thermoplastic composite processing. So which methods comes under the, if you are using the thermoset resin, then you will have there again two categories, whether you are using the short fibers or whether you are using the continuous fibers. So if you are using the short fibers, then this injection molding is preferred there, because the short fibers injection molding, short fibers can be handled easily. Then spray layup is also there. Spray layup also I will discuss you And the compression molding is can be used for the short fibers because there it is very easy to control. If you are using the under thermoset continuous fibers, then layup is common to both. Then filament winding, because filament winding there should be a continuous fibers. Okay, so it requires some rotation mechanism and these things. Continuous feeding of the fiber is required there. So for that purpose, you cannot use the short fiber. Short fiber, for if it's the short fibers, you cannot use this particular method because here you need the long continuous fibers. Then liquid molding, and again pultrusion. Pultrusion also requires because here we are the pulling the fibers. So there also for continuous long fibers, this method is suitable. If you go for the thermoplastic composites, then again in that thermoplastic also reinforcements again will be their fibers, whether this fiber are short fiber or continuous fiber. Based on that, you can just see these methods of manufacturing. So this is the again thermoset matrix. These methods comes under this. For thermoplastic, these methods under comes under this. So in that also some here methods can be common to both or unique. Okay, so now recently automotive industry is looking for the composite material and looking for the, because automotive industry is again huge. So mass production for in the automotive industry is more as compared to the aircraft and space vehicles. So looking to this demand from the automotive industry for the mass production rates. So these methods are generally compression molding, pultrusion, and filament winding. They are also being used. They are very much common in the for the. They are being developed and widely used. So, and resin transfer molding is another manufacturing process that has received significant attention. So in both aerospace and automotive industries, because in resin transfer molding, here you can use the make the very complicated shapes that is possible with the RTM. So what is RTM, that we'll discuss in detail in the further. So yeah, just now we are comparing here the difference between the metal versus composite manufacturing. So when you come to the making of products from the metal, then that techniques is totally different when you come to the for composite material, because in metals already you have the finished forms. So which are the finished forms? These rods, metal sheets, slabs. Okay, so these are the finished forms which are ready-made available, and these are stored as an inventory or in as a stocks. And anytime you can pick up the things, these things to make a finished products. Okay, so the making of finished product, that is from the these finished forms. Okay, so for example, this is the car door. Okay, so how this is made? This is made from these metal sheets, and by which process? So by using the die and punch. So using the hydraulic press or mechanical press, these are simply punched into the desired shapes. So that is a forming. Okay, so this is a finished product, and which is obtained from these finished forms, which is ready-made available. Okay, so the making of finished products such as car body or maybe the box frame of computer, it requires only on these finished forms. Means that directly we work on these sheets to get the finished products. So processes such as cutting, bending, forming. So what this process comes to get the products from the finished forms. So these are some few processes we have to do: welding, maybe drilling, and that will convert these sheets or the rods or slabs into these finished products. So that is possible, means intermediate. So in order to manufacture this in one go, you can in steps this can be manufactured, but this is not with the composite material. So for the composite material, a manufacturer using composite material has to work directly from the ingredients of fiber and matrix to the finished products. Means you have to go whenever, if suppose you want to manufacture this particular structure. So what you have to do, you have to start from the this scratch process. That is, you have to take the fabric, resin, then you have to mold it by using the different manufacturing process. Then you will get the product. So it is not like that. The prepeg is another one is there, but still that is the intermediate stage, but still it is not like a process like a metals, okay, because storing and these things are very difficult for them. So everything you have to start from this scratch to get into the finished product. So there is no intermediate steps like this manufacturing of the metal components. So this is the basic difference between. So you have to mentality of working with the metals therefore cannot be directly applied when manufacturing the composites. So this is totally different manufacturing of the composite material. Now, irrespective of whatever these manufacturing techniques you use, okay. So for everything, whatever these points I listed here, you have to take the utmost precautions for this. So means these things you have to ensure, one has to ensure to get a good quality products. So if these things are not ensured properly, then irrespective of the whatever manufacturing process you use, the products will be a defective and that will not fulfill the requirements. It will not be a functional. And what are these requirements? The good bonding between the matrix and the fibers. Yes, this should be ensured. Otherwise, if there is a dry spot within this, then it will have delamination, crack orientations. Okay, so these things will happen and it may lead to the catastrophic failure. So there we need to ensure that during the process there will be a good bonding between the matrix and the fibers. Proper orientation of the fibers. Yes, this is important because the proper orientation of the fiber, why it is important? Since the properties such as stiffness and the strengths, these are highly dependent on the fibers, and again these are highly dependent, very sensitive to the fiber orientation. So if the fiber orientation deviates by 10 degree from the zero direction, then the stiffness can drop by more than 30%. So means here orientation of the fiber while you are using the manufacturing, you have to ensure that, or the labor works we are working on that, you have to train them in a such way that this orientation will be very proper and very consistent. So because this orientation directly decides these two important properties, stiffness and strength. So to get the consistent well of the stiffness and strength, the orientation should not deviate. Okay, there should not be error in the orientation. Then good amount of volume fraction of fibers. I mentioned as the volume fraction of the fiber increases, strength, these two parameters, okay, with increasing volume fraction of the fiber, stiffness and strength increases because these are the important ingredients we decides these two parameters. But after this also up to certain limit, means it is like this. If I draw this graph, strength versus volume fraction, then this, as you go on increasing the volume fraction, okay, as you go on increasing the volume fraction, strength increases, strength and stiffness increases, but up to certain limit. Beyond that, it may start dropping. So you have to use a proper volume fraction, optimum volume fraction of the fibers in that particular. So this is also important, and this you have to decide based on the various judgment or the some calculations. Uniform distribution of fibers within the matrix of the material. So this is also important. You can see here now. So this area you can see, this is the resin rich area where the fibers are not there. Okay, so there is no uniform distribution of fibers in this. So if these things happens, so these all these circles I mark, these are fibers are not there but resin is there. So this is the weak portion. So you should know, it should be ensured that there is a uniform distribution of the fibers within that particular laminate. So that is very also important. Otherwise, it will form the weak sections, and that particular area will be weakened, and it may lead to the failure. Proper curing, curing is very much important, and this is may be done as the room temperature by using the autoclave, depending on the what type of products you are manufacturing. Limited amount of voids and defects. Yeah, voids. This should be a less than 1% void. If it is greater than that, then there will be a rejection of that particular product. Then good dimensional control for the final product. Means what happens, I mentioned earlier that degree of shrinkage. So when because this thermoset based process, it is exothermic, And if the coefficient of thermal expansions are not matching or they differ a lot, then there will be a shrinkage, and this shrinkage uh, maybe 5 to 8%. So what this shrinkage do? This shrinkage produces the residual stresses. So again, this will lead to the warpage of that particular structure. So there will be a warping, or it will, the structures will be out of dimensions, then it will create a problem. So this shrinkage, you have to control it properly, and by selecting the proper chemical compositions of the matrix. So these things are very much important while manufacturing. So good dimensional control of the final part, it should be ensured during the manufacturing processes. So why these things I mentioned here, irrespective of the what manufacturing techniques you use, so all these things must be taken care of to get the good quality products. So this is the background before we start discussing any of the particular manufacturing process. So today I will discuss about the hand-layup process, and as I mentioned, this is very primitive, this is very old method, and the main advantage of using this method, it requires very minimum equipments. You do not to have very instrumentation and control. These things are not required much, only the labor is required, and that's why you will find for non-structural applications or in small scale industries, even in some research institutes or in our colleges also, we do these things. We use the layup processes where, so this is an open mold method, because why it is called as the open mold, because there is, you can see, mold is on only one side. Okay, so here suppose this sheet is on to manufacture of this particular shape, so this mold is on only one side, there is no another mold covering top of this, so it is open to the, so all these fiber layers are in direct contact with the atmosphere. Okay, so that's why it is called as the open mold process. So it involves the manual laying of fibers. Manually we lay on this by some process. Any type of fiber, mostly the glass fibers are widely used. Natural fibers are also used for such type of manufacturing methods by using hand lay, jute fiber and these things. Here mostly the thermoset resin is used in liquid form because it is easy to control that. If you are going for the thermoplastic, then additional things are required. Heating process is required. Compression under high pressure is required. So the thermoset resin is mostly the epoxy and polyester is used. And the mold has shape of product, and the product has the better surface finish over the side that is in contact with the mold. Means the side which is in contact with this mold, the lower side, here you can see, the lower side will get the better finish. Glossy finish you will get the on lower side. On top of this, you may not get the that type of finish. Maybe there are some techniques you can use the Mylar film, but here mostly the surface which you want as a functional surface, mostly the bottom side, if it is a functional surface, that we can get the glossy finish here. The first layer on the, now what is the process? Suppose here the first we apply the gel here. Okay, gel coating is applied, and this is to get the high surface quality. Initially gel coating is applied here. Our alternative for this is a Mylar film, which is maybe mostly the glass type of plastic. So this is a Mylar film of 0.75 mm. So this is laid on this, or we can use the gel coating. Then reeling agent, mostly the wax we use as a reeling agent. So this is because once you allow it to cure, then this sheet should not stick to this mold. Okay, for the easy removal, releasing film is provided there. Then oven fiber layer laid with the decided orientation. Okay, mostly the oven fiber, why it is more popular in the hand layup, because it is easy to handle. Unidirectional also can be used, but the oven fiber is very easy to handle, and that's why it is preferably used. Then layer of liquid resin. So once then we can apply the liquid resin one by one. We can use this brush or hand roller. Okay. So here you need to take care that the catalyst and accelerator, these two things are mixed in the resin system, and you have to add this as per the proportions. So generally this ratio is for epoxy, it is the ratio of resin with the hardener is 100:10. Okay, and this is for epoxy. And if you use the polyester, then it is 100:1:1.5. Okay, this is for, so one is for catalyst and 1.5 is for the hardener or accelerator, sorry, not accelerometer, accelerator, hardener. So in simple we call it as a hardener. Catalyst initiate the reactions and the hardener will accelerate the reactions, chain formation. Means curing time can be increased by using putting the hardener. So this you have to mix in proper proportion, and you have to ensure that it will not get cured before you make the finished products. So that time you have to manage here. Accordingly, you can add the hardener here. Okay, accordingly you can add the hardener, accelerator. Or if you add this in less quantity, then curing time will increase. Okay, the curing time will increase. So brush is used to evenly spread the resin. A roller is used after laying each layer to remove the air entrapped. So there should not be the air. So you can see here, a roller is used so that the all air entrapped can be removed, and also excess resin. If there is excess resin, so that can be also removed. So we basically, by using the hand roller, you are trying to achieve the uniform thickness throughout, and at the same time you are removing the excess resin and the porosity also. Okay. So this is again this method is the layup process, which is supported by the compression molding, because for some particular fabric, if you just apply the resin like here and just keep it, then after some time it will come out, that layers will come out, may form, the bulging will form. So you need to compress this. So generally this happens with the jute fiber that I experience. So once you apply this one layer over the another, then you can put this under simple mechanical press or compression molding. So, and you can compress by using this under compression molding, so that it will take that particular thickness. Even you can provide the spacers here, so to achieve the uniform thickness. So for particular type, basically for the natural fiber based fabrics, you need to use this compression molding, which is supported with the hand layup process. So so these things I explain. So this is particular jute laminate. You can see this is manufactured by similar type of, this is not the exact same, but similar type of laminate is manufactured by our students in our workshop only. We have one mechanical operated compression molding machine in workshop, where we can first do this layer of things, and then we can compress when the 10 layers are laid one over the another by applying the resin on each layer. Then whole thing is kept under these compression plates, and they are compressed under certain pressure by keeping the spacers on each side, so that you will get the uniform thickness. So I was explaining about the things, this open mold, that is a hand layup process, and in that we are using this motor open mold. So here the things is that most important thing you need to apply is the releasing agent, gel coating or mylar film, and then you can put these fabrics one over the another and go on applying the resin with the help of brush or the roller. Rollers are generally used to remove the excess resin and the air bubbles if there are any things. So which this board, what kind of products we can manufacture? Even this large size of boards also generally are manufactured by using the this. So it is possible to make products with glossy, matte or textured finish on the surface by using mold with respective finish. Even you can apply the colors on this. If you apply the color on this, so that particular side also of the finished products, you can have a as customized color applied, color paint applied on that. So there, that is also possible. Even sometimes people mix the color in the resin itself to give the desired color for that particular product. So that is also possible. So these are the again same things I explained. So this is the boat, one particular, you can see this is manufactured. Now here the one part is the functional and another part is the non-functional. It can be a coarse. Okay, so only the inside part, it can be a outside part should be a functional. It should be a smooth finish because this should not create any problem. So in a inside part you can make it later on, you can process it. The process remains important for one low volume manufacturer. The main drawback of this hand-layup process is that you cannot go for the bulk mass production because production rate decreases. Here manual intervention is required, and it depends on the how much skilled labors are there. So volume manufacturing is less for the hand-layup process. Hand laminating using open molds has traditionally been used for making structures out of fiberglass, polyester, but there are environmental concerns. So this here, there is a what happens because if you use the thermoset resin, then it is an exothermic process, and it there are gases, they are evaporating from this process and they are released into the atmosphere. So if the workers or labor are directly coming into contact with this, then this is a hazard, health hazardous. So proper protective gear should be used there so that these gases should not be inhaled. Otherwise, it will create health issues to the workers. So this evaporation of steering into the atmosphere. So that's why closed molds are sometimes preferred to avoid these things. Okay. So there are few techniques of liquid composite molding that may produce similar parts with the closed molds, thus avoiding the environmental issues. So that is one of the drawback with the hand-layup technique. Here you can go for the for alternate layers with different fiber orientations, and that is also possible with the hand-layup method. So to get the tailored design, generally this fiber orientation or stacking sequence is possible with the hand-layup method also. Okay, what are the advantages? So we'll just read one by one. What are the advantages of the hand-layup process and what are the drawbacks? So large scale use of hand-layup process is attributed to the simplicity of the, means it is very simple. It does not require any advanced technique. What it require, you require mold, one side mold, then you require brush, then some pots to mix the resin, and roller. So these are things you can easily purchase from the hardware shops, and you can start. Means at the student level, generally projects, students do use this particular technique. For research purpose, definitely this can be used. No expensive equipment are required. So practically there is no restriction on the size of the product. See, large ship or boats, they are manufactured by using the hand layup process or spray layup. What is spray layup? That I will discuss in next slide. So it is possible to mold all shapes and incorporate the inserts of any shapes in that. Depending on the end user's taste, color, decorative finishes can be incorporated in the. So means shapes means you can get any shapes. Only thing is that that particular mold you have to prepare. Only the requirement is that. So this is the most suitable method for lining tanks. Means for repairing purpose, hand layup method is generally used. Okay. Means if you want to fill up some holes or something, crack portion, then that kind of repair can be done by using the hand layup process. You cannot take the equipment of machines there for the large structures. So repairing in the marine applications generally can be done by hand layup process. Limitations, so labor intensive. You need to train the labors. You need to retain the labors once you train that, because here, because of the health issues, it is one of the challenge to retain the labor. Good surface finish on both sides. what we seen that you will get the good finish only on the sides, on the mold side, but opposite side you will have the rough finish. But if you want the good finish, glossy finish on both sides, then this process may not be much suitable. So this process cannot compete with the compression molding for the mass production, yes, where the automation is generally done. The thickness control is another issue, because this thickness, it directly relates to the volume fraction of fiber, and this volume fraction of fiber is directly related to the Young's modulus and the stress. Okay, so thickness control is very difficult here. Maybe you can use some spacers, but there you need to compress. So if you are using the mold from one side, so you don't have any control over the thickness. So that is another challenge in the this. So that's why this cannot be, because thickness decide the volume fraction decide the strength. So for the structural applications, this method cannot be used indirectly. That's what we can conclude from this. Now I will talk a bit about the this hand layup, spray layup process, and I will show you one video, one or two videos on that. So from the videos it will be very clear how the spray layup works. I will explain here a little bit. So here, what is this? You can see this is fiber, continuous feeding of the fiber is there in this. Okay, and there is a one mechanism here. Okay, where the fibers are chopped, these continuous fibers are chopped into the short fibers. Okay, so there is one cutting mechanism, you can say, is there, where this continuous fiber is fed to this particular portion, and it will cut that fibers into the small short fibers. At the same time, resin is fed from the another input, and where the resin and these short fibers are mixed together here. And once this mixture is done, then this, with the help of this nozzle, it is sprayed on the mold that you prepared. So this mold is prepared again by similar that for the hand layup, applying the gel coating or releasing agents. Once mold is prepared, then you can just spray this mixture. This mixture is of the resin as well as fibers. So this mixture is sprayed, and you will get this layer of the composite material on that particular this. So you can just go on spraying on this. You can use some operators. So spray is another low to medium volume open mold process suitable of producing medium to large size greater shape complex. Here one thing is that even you can reach to the at the corner. That is the main advantage. At very small sections, this composite mixture can be reached, because here you are using the pressurized air, compressed air under high pressure. You are under high pressure, then it will, through the nozzle, it will be give a high velocity to that, and with this pressure, it is just like a water jet. And you can see here, it is just like water jet, and at any corner you can spray it. So complicated components can be complex shapes can be covered, or cavities can be covered with the help of this spray process. Now here the thing is that you need to control there is a separate nozzle for resin. You can see here one nozzle spray resins premix with the catalyst, or only catalyst alone will be there in one nozzle, and another nozzle will have resin premix with the accelerator. Because when this accelerator and catalyst both are mixed together, then it will start immediately a curing process. The accelerator mainly accelerate the curing process, so it should not get cured in this spot only. Okay, for that purpose, two separate nozzles are there, and then they are sprayed alternately, so that curing will happen at the mold and not in the mixing chamber. Because if the mixing chamber happens here only, then it will get blocked. So that care you have to take it if you are manufacturing the large structures. So you can see this particular cover of the pressure vessel is or tank is being manufactured. So this is a mold actually, and here the by spray layer, this particular is being manufactured. So even this composite pressure vessel made up by a combination of hand layup and filament winding. So this is a combination of hand layup as well as the filament winding. So these things are where we cannot do the filament winding, so their hand layup process is used. So and these fibers in this we can use these fibers in different form. Bulk form, okay, fiber form means the reinforcement. What kind of reinforcement in the form? So bulk form means maybe short fibers, then fibers, then powder form. It will be available in the flake form. So all these things you can use as a reinforcement. So here I will stop my presentation, and whatever the spray layer process I explained to you, that I want to show you, because once you visualize, so this video I will just share with you. 2-3 videos are there up to 2 minutes. You just go through it, and then after that I will take your questions.
The spray-up technique is a partly mechanised version of the hand-layup process. Spray-up is an open mould fabrication process where resin and chopped reinforcements are sprayed onto a reusable mould using a chopper gun.
Okay, so the next equipment we're going to move on to is the resin depositor, and this has a chopper head on it. So once again, it's a high pressure style delivery gun, and it's the difference between that and the gel coater is it is slightly lower ratio for pump pressure. We don't need higher pressure with this because unlike a airless system, this is an internal mix gun. Okay, so this means that the resin and initiator is mixed inside the head. So this requires a solvent flush system. You see over here, that's the acetone, sorry. It's the solvent, and that flushes the head. Okay. So this requires a solvent tank. This particular tank here is air over catalyst. So unlike a slave pump where it relies on hydraulic pressure, this works independently from the resin pump. So what we're doing is we're converting air pressure, and we're pressurising the tank. So this works independently of the pump, and it's what's known as an air over catalyst system. Lower pressure, internal mix at the head, and up here we have a cutter. This is the chopper part of the gun. What this is an air motor that will drive a spindle which contains a blade holder, and we have some consumables in this head here. We have blades around the holder, we have rubber for a cot. Also we have some adjustments on it. We can adjust the tension of the rubber. We can have the any amount of blades that we require, the strand length. And we can make adjustments for motor speed. So we can adjust the speed of the motor, and we can, with this adjustment here, we can introduce air and fan out the glass, and we get the right adjustment to go into the fan of resin. What feeds into this cutter head is what's known as continuous roving. Okay. Unlike chop strand mat where we can weigh it per square metre, it's pretty well impossible to do with this system. So what we do, we measure it by what's known as tex, and the tex of this particular roving is 2400. That means it's 2400 grams per 1,000 metres. So if we're to take this out for a kilometre, bundle up and weigh it, it will weigh 2.4 kilos. Now, being an internal mix, we need, as I said, we need a solvent flush. This bit here, this is an atomizer. Okay, so unlike the airless systems we're using in a gel coater, they're not relying on air to atomize, to create a spray pattern. By reducing the amount of air, we can reduce emissions. So as part of the training for gun operators, they learn how to control emissions.
The spray-up process is a method in which resin is sprayed onto the mould at the same time as the chopped rovings. The spray gun is moved in a predetermined pattern to create uniform thickness of laminate. Considerable skill is required to control this. The air pressure in the lines to the spray head and chopper are preset within certain limits to regulate the ratio of glass to resin that has to be simultaneously deposited. Additional layers of chopped rovings, woven roving or mat and resin may be added to build up the right component thickness. The sprayed fibre and resin material is compacted using a roller to consolidate the mixture and to create an even and smooth laminate surface. This also ensures that the laminate properly adheres with the gel coat surface and removes any air in the resin matrix. The whole laminate is allowed to cure at room temperature, after which the part is then demoulded and sent for finishing work.